Now let's look at some of the rules that we use in computing probability. All right, let's look at some of the rules that we use in computing probability. Now we have seen independent events over here, right? And then we have also seen the formula for independent probability to be this, right? Which we have already used over here. Okay. Now this is just a further example of that, because we're going to actually see a different version of this later on, right? You can maybe go through this example, but it's just you're going to roll two things over here. You roll a die, right? A 6-sided die. Remember, a die is having numbers from 1 to 6, and then you also flip a coin. Okay, then when you roll the die, you're going to record a 1, right? The probability that you get a 1, that is 1 out of the 6 probabilities. And then the probability that when you flip the coin, you're going to get a head, which is also going to be 1 out of the 2 probabilities, right? Because a coin is having either a head or a tail, so it has only 2 events over there. So for you to get a head, it's just 1 out of the 2, and for you to get a 1 in a coin, it's 1 out of the 6 probabilities. So if the question is asking you the probability of rolling a 1 and getting a head, then it's just going to be 1 over 6 multiplied by 1 over 2. Okay, and then you get your answer over there. It's just similar to what we did earlier on. All right, now that is independent event, right? That is an independent event. Now this is another version of it where we have dependent event. Okay, this is another version of it where we have dependent event. Now, for dependent event, right? For dependent event, we say that the probability of something happened, given that something else has already happened. Okay, the probability of one event happened, given that another event has happened. Okay, so if you have planned to go to, say, a party, or you have planned to go to or travel to a certain state, right? What is the probability that you still go, given that it is going to rain tomorrow? Or given that it has already rained, what is the probability that you're going to still continue with the plans that you have? All right, so that is conditional probability, right? That is a dependent probability. You are basing on the probability that something has happened to make a decision on the probability that something should happen. Okay, so maybe earlier on you were not even planning to buy a car or build a house, but now you got a good job, you learned data science, you went through the course very well, you got a good job, and then you got a good salary, right? Now your plans will now change, right? What is the probability that now you buy a car or build a house, given that you've gotten a good job and then a good salary, right? What is the probability? So sometimes you want to analyze that kind of situation, and in such cases it's going to be a dependent event. Okay, you are making a decision depending on what has already happened. All right, so if you see this one here, we are saying the probability that events A and then B both occur, right, is equal to the probability that event A occurs times the probability that event B occurs, right? Given that A has already occurred. Okay, given that A has already occurred, so that's what you see over here, right? The probability of A occurring multiplied by the probability of B occurring, given that A has already occurred, right? If you see the one that we were dealing with earlier on, we are saying the probability of A and B happening, right? It's just probability of A multiplied by the probability of B. But in this case, we are saying that probability of A and B happening, given that A has already happened, right? So the example over here is saying that we have a basket which contains 6 red, right? It contains 6 red marbles and then 5 black marbles, right? And then we're going to pick 2 marbles, right? We're going to pick 2 marbles out of the bag that contains 6 red and then 5 black, right? In this case, we are doing it without replacement. When we pick the marble, we are not going to put it back in the basket. Okay, when we pick the first marble, we not put it back in the basket before picking the next one. Now we want to know the probability that both of the events or both are black. Okay, we want to know that kind of probability. Now if you see this kind of scenario, right, we are saying that we have red marbles to be 6, right? We have red marbles to be 6, and then we have black marbles to be 5, right? We have 5 black marbles. Right, so now the total over here in the basket, right, the total marbles in the basket is going to be 11, right? It's going to be 11. Now we're going to pick a marble out of this bag, right? So we want both marbles to be black, right? Remember the total black marbles is 5, so that's going to be 5 out of 11, right? 5 out of 11. So we have 5 out of 11 choices to make to pick a black marble for the first time. When we pick the marble, we are not going to put it back. So when we go again to pick black marble, now the black marbles has reduced to 4, okay, because we have picked the first black marble, and then the total has also reduced to say 10, right? We have picked the first black marble, so the first, the black marbles have reduced by 1, the total has also reduced by 1. Okay, and then that is what is going to give us this kind of probability. So the probability of picking the first black marble is going to be this, right? It's going to be 5, let me use bracket over here, it's going to be 5 out of the 11, right? And then we multiply it by the probability of picking another black marble, given that we have picked the first black marble. So that's going to give us 4, right, out of 10. Okay, so when you multiply this one, you're going to have your probabilities over there. All right. Okay, so now let's move on to addition rule, right? So we're dealing with multiplication rules over here, right? Now let's move on to addition rule. We've talked about mutually exclusive events, right, where we say that where both event A and then event B, or the two events, have nothing in common. Okay, they have nothing in common, or they are disjoint. Remember that we've discussed mutually exclusive events over here. Okay, and then we say that both events cannot occur at the same time, right? They cannot occur at the same time, such as flipping a coin. You cannot have a head and then a tail at the same time. All right, so this is the addition rule for that, right? So in probability, we use this sign over here, right? That is probability of A or B occurring is equal to the probability of A plus the probability of B. The or is provided as a plus sign over here, right? In probability, when there's any or there, we represent the or with sign, and if there's any and, we represent the and with multiplication. Okay, so if you see the example over here, which will make it more understandable, we're saying that the student goes to the library, right? The student is going to the library to get a book, right? The probability that she checks out a work of fiction, right, that is the probability that the student is going to pick a fiction book to read, is 0.40. And then the probability that the student is going to read a non-fiction book is 0.30, right? Now, the condition here is that the student can only check out one kind of book. So it's either the student is going to pick a fiction book, or the student is going to pick a non-fiction book. You cannot pick both of them, right? Now, we want the probability that the student checks out a work of fiction or non-fiction. All right, a work of fiction or non-fiction. So in that case, we have the probability of the person picking a fiction, right? So it's going to be something like this: the probability of person picking a fiction book, right? Fiction, or, so let me use the U sign over here, or non-fiction. So I'm going to use N over here. Okay, so this is the probability of the person picking a fiction or non-fiction book. So that's going to be the probability of the person picking a fiction book, right? Or, so the or here is going to be plus, right? Or the probability of the person picking a non-fiction. Okay, that's how it's going to be. So we have already seen this, so it's going to be like this: the probability of picking a fiction book is 0.4, so it's going to be 0.40, right, over here, plus the probability of picking a non-fiction book is 0.30. Okay, so when you add the two together, that is what is going to give you your total. That is going to be 0.70. Okay, so this is going to be the probability of the person picking a fiction or non-fiction book. Okay, now let's look at non-mutually exclusive events as well. Okay, so first we have seen mutually exclusive events. We're going to see non-mutually exclusive events. Now, over here, we're saying that the probability that event A or event B occurs is equal to the probability that event A occurs plus the probability, right? The probability that event A occurs plus the probability that event B occurs minus the probability that both of them occurs, right? Both events A and B occurs. All right. Now, let's use an example for this so that you get an understanding of that. Now, this is an example from an extension of the example from from this one, right? We're just going to to it, just the same example. Now this one is saying the student is going to the library, and the probability that the student checks out a fiction book is 0.4. The probability that the student checks non-fiction book is 0.30. Okay, and then the probability that the student will check both of the books, that is both fiction and then non-fiction book, is 0.20. Okay, 0.20. Now the student can check out both kind of books. This one, they have allow the student to check out both kind of the books, right? Remember earlier on, the student can check only one kind of a book, but in this case, the student can check either of the books or both kinds of the books. Okay. What we want over here is what is the probability that the student checks out a work of fiction or non-fiction, but not both. Now you see the condition that we are giving here. The student can check out one of the books here, but the student cannot check out both of the books, although they have the flexibility to check out both of the books. But we are given a condition that the student can just check one of the books but not both of the books. Okay. Now if that is the case, then you need to make sure that you take out the condition that gives them the flexibility to check out both. Okay, that's why we have the minus the probability of A intersection B, or the minus the probability of both A and B occurring at the same time. All right, let me explain it one more time so that you get an understanding of that. So we say that the student can check out a fiction book and the probability is this. The student can check a non-fiction book, the probability is this. Okay, and the student can also check both fiction and then non-fiction book, and the probability of doing that is this. And we have given the student the flexibility to check out both books. All right. However, when we come to the question, we are saying that the student can check out either of the books, whether fiction book or non-fiction book, but the student cannot check out both books. Right? Although they have the flexibility to do that, right? They have the freedom to do that. But right now, the probability that we want to check, we want to restrict them from checking both of them. In that case, we need to take out the part of the formula which gives them the flexibility to check out both. Okay. So that is going to be this. That is going to be something like this. Now the probability of let me do this. The probability of fiction is going to be this 0.40, right? 0.40 plus let's getting a fiction, the probability of getting a fiction book, or the probability of getting non-fiction, which is 0.30, right? Minus the probability of checking out both of the books, which is 0.20. Okay, and this is going to end up giving us something like this is 0.7 minus 0.2 is going to give us 0.50. Okay, so that's going to be the probability of checking out either fiction or non-fiction, but not both kind of books. Okay, so that is non-mutually exclusive. All right, so I hope you have an understanding of these concepts that we have discussed so far, right from why we need probability, and then the various concepts that you need to understand, and also the range of probability, the expression of probability, and also you have seen a sample of using probability in machine learning, which we are going to do it a lot when we get to the machine learning class. And then mutually exclusive events, some examples over here, independent, and then multiplication rules and dependent events, conditional probability, which we're going to base on this conditional probability to talk about one more important concept, which is Bayes theorem, right? Bayes theorem is going to base on the conditional probability. It's an extension of that. All right.